Thanks so much for joining us for our webinar today. My name is Mark Tarina, and I am the Marketing and Communications Manager here at NWPX Infrastructure. And I'm super excited to continue our webinar series today on the topic of rethinking manhole rehab. We're going to be talking about the Hybrid PVC Manhole System. This is a permanent structural rehabilitation solution for corroded sanitary sewer systems. We're not only going to just go over the technical aspects of the system and how it comes together, but we're going to look at a real case study from a project in Utah that utilized the system to rehabilitate a severely corroded 48-inch manhole. So we have a special guest, Trevor Andra from the Magna Water District, who's going to be joining us for a discussion on that a little bit later during the presentation. But first, I want to go ahead and introduce our presenters for the technical content. So please welcome NWPX Geneva's Line Product Manager, Dr. Elena Mikhailova, and our sales representative, Jake, Minnesota.
Mark, thank you for introducing us, and I would like to welcome everybody to this webinar. I know how busy you are, and I'm very happy to see you at today's presentation, where we're going to be going over the case studies and this technology that may help you on your next project. My name is Elena. I'm a product manager for Geneva Pipe and Precast for our line precast specifically. And I've been with Geneva since 2021. And Jake?
Yeah, I'm Jake, Minnesota. I'm the outside sales representative here at Northwest Pipe for all the lined manhole and all line segments here. And yeah, happy to be here. Excited to engage with you guys about our product.
Thank you, Jake. So today we're not going to be talking just about the patches. We're going to be talking about the permanent rehabilitation of the manhole that hybrid PVC manhole could provide to you. We're going to talk through one of the case studies that we've done in our hometown, Utah, and Trevor will join us for a more detailed discussion. He was heavily involved with this project, and he's going to give his perspective how this project went and how much effort it took and how much they like this product. Before we jump into a quick note on our name, our Northwest Pipe Company has rebranded as a NWPX Infrastructure, and under that umbrella, Park USA is now NWPX Park, and Geneva Pipe and Precast is now NWPX Geneva. So nothing about the quality or people have changed, only the name. So hopefully you will see the quality of our product through the context of this presentation. So about our geography, we're located throughout the US, and our precast in particular located in Utah and Texas. And all of our lines structures are manufactured in Orem, Utah or Houston, Texas. So I know some of you are attending from those states, so it's readily available in your areas. So for today's agenda, we're going to be talking, first we're going to talk about what microbiologically induced corrosion is in sewer manholes, how it affects the structures. Then we're going to look over the permanent structural rehabilitation options. That's going to be the topic of your interest. And we're not going to just look at over our solution, what we will offer, but we also will compare it to the traditional methods for rehabilitation of manhole structures like spray-on liners and cured-in-place manholes. And of course, mid-presentation, we're going to start talking about the case studies that we've done for this particular project with Magna Water District. So what is a microbial-induced corrosion, or MIC? So microbial-induced corrosion is a leading cause of deterioration of concrete sewers. We know the concrete in general can last a very long time, especially like in storm water condition. We know there is infrastructure that lasted more than 100 years for storm sewer, and I believe there is an active sewer line in one of the parts of the US where the concrete sewer was installed more than 100 years ago. But unfortunately, concrete does not last as long in aggressive environments such as H2S gases in wastewater environments. It reacts. It's a natural result of a chemical reaction due to the bacteria and the acids that created by those bacteria, and oftentimes it goes undetected from our experience. Sometimes when we talk to the agencies, and when the majority of the structure is made out of concrete, especially smaller districts, when they don't have the asset management programs, and they do not inspect the structures and assets on a regular basis, sometimes microbial-induced corrosion happens undetected, and all the efforts that to fix the issue become an emergency. This particular photo on this slide is out of St. George. When you first look at it, you may see nothing wrong with it, but it's very important to recognize how the microbial-induced corrosion looks like. For this particular one, you can see the pebbly structure, right? So when concrete manholes, the troughs in benches poured, typically the bench area is very smooth, and you should not see the aggregates. For this one, there is some microbial-induced corrosion is happening, and you can see that pebbly structure. So how does the microbial-induced corrosion happens? So there are bacteria in wastewater. I know majority of you in wastewater, and you know that you know the chemistry, but I still wanted to go over it. So you have bacteria in wastewater structure, in wastewater, and there's sulfates in standing water, and it's reduced by bacteria in oxygen-free conditions, and it forms, because of that, it forms hydrogen sulfides, or known as H2S gases. And then H2S gases rise. Typically, they settle at the top of the manhole and the top portions of the manholes, or crown side of the pipe. And once it settles down, it reacts with bacteria on concrete and oxidizes into sulfuric acid, and then sulfuric acid reacts with cementitious materials in concrete, and it creates gypsum. And gypsum in moist environments, it swells and it starts crumbling. So that's kind of like a very simplified version of how concrete deteriorates under the H2S gases environments. Yeah, there's a biofilms created, gypsum, and concrete gradually starts crumbling, and you have a loss of the thickness of the wall, and then it eventually can get to your reinforcing steel. Microbial-induced corrosion is accelerated in certain environments, such as heat and humidity. When you have a longer transit times, that means you have your structures subjected longer to H2S gases. Then turbulence, when you have lift stations, pump stations, and of course, it's your wastewater makeup. Not always water makeup created equal. It depends what flows through your structures. Corrosion happens faster in heat and humidity. When you have high turbulence, pump stations, lift stations, and of course the wastewater makeup. For example, like we've had instances where the municipalities with dairy farms or dairy manufacturing, where they have milk products, they have elevated temperature wastewater products, and in that environment, concrete manhole unprotected can deteriorate as fast as 5-6 years. So those types of environments specifically need very aggressive measures for protecting the manholes from deterioration. Here's another example of microbial-induced corrosion affecting a manhole. So this one particular one was taken in one of the wastewater treatment plants in Utah. We knew that this municipality had 80% of the assets made out of concrete. And we asked them if they were aware of the struggling with any microbial-induced corrosion, which they didn't know of any issues. And then when we went and asked them to pop the lid on one of the manholes, because it was like right in front of the office. And when we opened the lid, so this is what we observed. You can see that there is some flaking of concrete from the walls. There is some discoloration. Apparently, it's very obvious they're experiencing microbial-induced corrosion. So how do you detect corrosion? So previously, I already mentioned pebbly surface. You also just saw flaking. When you see white or black discoloration, so white typically indicates gypsum formation, and under the wet or humid environment, it starts being soft and starts crumbling once it dries out. Then black indicates sulfide presence, and then you're going to have that typical rotten egg smell that indicates the anaerobic condition. Here are other examples that we obtained from some municipalities. This particular on the left, that was a sewer line, sewer line that was discovered during one of the CCTV inspections. It was St. George location. As you can see, there's some parts of the pipe were completely gone. You can see some soil visible. In some instances, this could be a catastrophic failure, especially if it was like under the highway. Luckily, it was not, and there was no collapse of this particular structure. But this pipe severely deteriorated. Also note that majority of the corrosion and deterioration happened on the top half of the pipe. That's where the gases rise and settle on the walls. And on the right-hand side, this was for one of the lift stations. It's a square structure. It has been previously rehabilitated with epoxy coating. However, epoxy coating kept failing. It was discovered that there has been a breach in epoxy coating, and behind the epoxy coating, gases would get in and still eat up the concrete. I'm going to play a little video of, you can visually see how microbial-induced corrosion looks to the touch. I hope this video plays well. So this was in preparation to rehabilitate this manhole. So this guy was literally physically removing some debris from the walls of the manhole, and also demonstrating how microbial-induced corrosion looks like. And this particular manhole has been rehabilitated previously with spray-on liners. So you can see some of the reminiscence of the spray-on liner that failed. So microbial-induced corrosion costs money to municipalities throughout the U.S. It costs in operation and maintenance. They have to go back and inspect every so often to see if this manhole needs replacement or rehabilitation. Of course, because of the corrosion, you have a reduced service life. Instead of desired 70 or 100-year design life, or even 50, sometimes you get 5 years, sometimes you get 10 or 20 years. Again, it depends on what flows in your sewer, especially with the more energy efficient appliances. Now the the wastewater that flows through our systems is much more corrosive than it used to be. And of course, eventual replacement, and of course, the worst would be the worst risk of collapse, where you have to do the emergency services, which costs the most money instead of pre-planning. So let's look at the solutions that are available. So here's one of the options is a cured in place manhole. So this has been one of the solutions that some municipalities choose. So what you have here is you have fiberglass sleeve that's sewn together specifically to fit this particular manhole. Of course, for this solution, you have to cut off the steps, and you have to prepare the surface so you have good adhesion. Then you have a sleeve that is measured specifically for that manhole. It has to be perfectly sized, so it's not too small, not too big, so you don't have wrinkles, or it touches every inch of the wall as well. It is a better performance than spray-on liner. So the layers of the fiberglass impregnated with epoxy resin. There are different types of application where you have impregnated. Sometimes they impregnated at the job site with a roller on. Sometimes they pull through the bucket with epoxy resin. And sometimes when they're not too heavy, sometimes they're pre-impregnated at a factory and then brought over to the job site. But sometimes when it gets too heavy, when you have long lines, for example, for the pipe, they impregnate the sleeves at the right at the job site. And once they lower it all the way to the bottom, they introduce the air so it expands and adheres to the walls, and then they either cure it with steam or UV lights. So UV light option is typically less smelly, so it doesn't create much disturbances for the neighboring residents. Whereas where you have the steam curing, it's more smelly, and there is a styrene VOC gases. So this solution is very good for I&I. It kind of seals infiltration with this method. From the sources they have found, it costs about $500 to $700 per linear foot, as compared to $100 to $150 for cementitious materials. So again, the benefits is, yes, it's very good for I&I. It's some of the cons, it's more difficult to conform to complex shapes, like where you have, if you have some benches or you have troughs that you need to line. You would also need to have a bypass for this solution, unless you're not rehabilitating the bench and trough area, then you don't necessarily need a bypass. And again, it still relies on chemical adhesion, so preparation of the surface is paramount to make sure you have a good adhesion. And most of the times it fails because it doesn't have a good adhesion. And again, this is not a structural solution. It does add some strength to the structure. However, it cannot support or provide support like a manhole itself for like traffic loading, or it doesn't add strength for hoop strength. Now let's move over to the most popular and most common solution for rehabilitation. It's coatings. There are spray-on coatings, there are roll-on coatings, and there are different types of coatings. So it depends what you prefer, what you tested, and what kind of environment you have. So typically it can be cementitious, epoxy, polyurethane, or polyurea. And each one of these types, they differ on application methods, curing time, curing conditions, preparations for the surfaces, and also your choice would depend on what kind of corrosive environment you have. But for all of them, these are temporary solutions. As I mentioned, it can be either spray-on application, it can be coated or rolled or brushed on. This application or this type of coating rehabilitation is ideal for emergency rehab, where you, let's say, thinking about replacing your structure in 5-6 years, and you just want to prolong a little bit longer. So this would be a good solution. So for short-term restoration, it's typically cheaper upfront, but if you're relying on this to prolong the entire life cycle of your structure, then it's actually can become much more expensive, because on average, this type of lining can last anywhere between 5 to 7 years. So that's the average lifespan. We've heard where the spray-on coatings, they start failing in 2 years. Sometimes they fail in 20 years. Some municipalities had really good experience, and some municipalities had really bad experience. And over we're hearing that it's not about what you use, what kind of material you use, but who the applicator is, right? How well you prepare the surface. Do you dry it well? Most of these types of coatings, they need bone dry surface. Otherwise, it's not going to adhere. And this type of coating or rehabilitation relies on chemical adhesion between existing wall and the lining. So again, it's a budget friendly. It's not a good solution when you have severe corrosive environments. It's probably for mild or moderate environments. And again, if you want just temporarily extend the life, and you have a more longer solution for later. So majority of these coatings, they fail because of the cracking, adhesion issues. I gets in between the liner and the wall. It can create back pressure behind the liner, and these liners typically don't have, like unlike CIPM, they do not have a fiberglass fabric. They don't have fiber inside it. It's just epoxy or polyurea, which is very brittle. So if you have a back pressure behind the liner, it can crack the actual liner. And once you have a crack, you can have gases going inside the crack, and it's going to start gradually eating up concrete behind it and kind of damaging the adhesion between the liner and the wall. So again, the average lifespan of these 5 to 7 years. I just talked about the failure modes. I would say 60 to 70% of this type of coating fail, and it's most of them because due to poor application. So if you want something permanent, you've got to look for something else. And one of the permanent solutions that I would like to introduce you to guys is our hybrid PVC manhole system. So this you can think of this solution as a slip-in lining, where you have custom-made pieces that would slip into your existing manhole. This solution in particular, it does not necessarily require bypass. It's simple and pretty fast installation. It has a minimal number of joints. I think like this is one of the highlights. You only have the joints at the bottom and at the top where it connects to the lids. So you have a minimum number of potential leaks in the system. It provides structural support. So if you have a manhole that which you're thinking maybe to replace, you can actually rehab, so install this manhole inside your existing manhole, because the PVC hybrid manhole does not rely on the strength of your existing manhole. So it's kind of like a standalone structure inside your structure. So we also offer 10-year warranty against corrosion, but it has 50-year design life. So it lowers the life cycle costs compared to some other methods. One of the consideration, if you're thinking whether it's a good solution for you or for your case, it's only available in certain sizes for PVC. For example, for the manhole with PVC riser, we have solution up to manholes with 72-inch diameter. And you also will get a reduction in the diameter of your manhole. So for example, if you have a 72-inch manhole, once you do the insert, it will become 60 inches, okay? So for the most cases, it's not a big deal, right? We only need big manholes to connect to pipes. That's how we determine the sizing for the manhole. The bigger the pipe, the larger and bigger, more penetration it has, larger the manhole needs to be. But as long as we can put a man inside the manhole to service the line, that should not be an issue. If you trying to rehab a lift station, let's say a round lift station where you have the equipment, yes, reduction in the diameter could be an issue. So let's look at the short video of how the technology, how it's typically applied. So you do need to remove the cone. And you have a custom-made base liner. And then you insert the riser liner. Grab the space around it and install lined lids. Okay, so here are the details. We will manufacture a custom-made base liner that will fit the configuration of your troughs and bench exactly. And then you connect through the Q's lock or any other sleeves to your existing line, and then put the riser liner. Again, notice that there are no joints in between. It's a one seamless riser where it reduces the potential for infiltration. And you have also provided with a line lid. So what is the preparation? So you've got to scan a manhole, right? So if it's a 018 straight through, you don't necessarily need the scanning. We can just figure out per as built. But when you have older manholes, and this is typically the manholes that require rehabilitation, where you have odd shaped troughs, so it's highly encouraged to have a scan of the manhole done, so you don't have to spend too much time chipping off to fit the liner, right? So if we have the scan, we can precisely manufacture the liner that you have to drop into the existing manhole. So you will need to remove the steps from the manhole to feed the riser in there. So surface preparation doesn't need anything specific. So you can see the picture, the guy's working in a live environment and he's cleaning the manhole. Here is removing big debris into the trash bag. Then you spray it with a high pressure. And then once it's done, you lower the base liner and you notice this is a live flow. You can stand on the bench and do all the work from there. You never had to bypass. And then you need to grout this base liner in place, so it kind of like gets embedded into your existing structure. To do that, you first have to bridge the gap between your existing line and the base liner. So we install the kind of like a coiled sleeves, then impregnate it with resin. And once you insert into a wet environment, it starts activating and expands. And then you inflate the bladder and it will adhere to the walls. So once the liner is fastened and grouted in place, you apply the mastic around the base liner and lower the riser, which is a PVC riser. Remember that your diameter is going to decrease a little bit, so you're going to have that annular space in between the existing wall and the riser. So you've got to grout it. So then you install the lids and backfill around the pipe, around the PVC, and then pour concrete around it. You also have an option of using composite rings to prevent corrosion. Again, this is the scan that we typically will need to get, as you can see for this particular project that we've done, not in Utah. We had a very odd shape troughs. So if you want to have a precise base liner, we will need to have a scan of it. And this is how we make our liners, very custom made. We spray it in several layers. This has a glass chopped fiber inside, which adds not just compressive strength, but also adds tensile strength. If you have a back pressure from behind, it's not going to crack. And those bridges, bonding bridges that you see, the black ones, they add the bonding anchors. Once you pour a grout, it's going to be anchored into the grouts. So this is one of the, so it's a corrosion resistant material. It has been tested for corrosion permeability. And if you need steps, it's possible. We discourage to have steps because you don't want to add additional penetrations, but it's possible. We have polypropylene lattice, which offers minimum penetration points. And if you have, you can have penetrations in the wall of the riser, and if you have drop pipe, you have an option of also having a drop pipe with drop bowl. So, and we also have an option of rectangular square structures. It's a FRP panels. They are fantastic if you have severe loss in the wall, so you can use them as a formwork to rehabilitate the structure. And you can add the reinforcement behind it. So for severely deteriorated structure is ideal solution. So, and this is how it would look after. So with that, I'm gonna hand it over to Jake and Trevor. They're gonna talk about the actual project case study that we have done in Utah.
Awesome. Thanks so much, Elena. I really do appreciate it. Yeah, so again, this is Trevor and Jake, and we're happy to kind of go walk through kind of our case study that we did here in Magna Sewer District.
Yeah, thanks, Jake. So Trevor Andre, I'm the district engineer here at Magna Water District. We serve a population of a little over 30,000 people. Fairly large sewer system. We've got around 2,600 manholes through the system. And then for myself, I've been the district engineer here for 5 years and come from a municipality, consultant background.
Awesome.
Before we jump into this, I just want to give a shout out to the crews that made this possible. They performed the work and made it possible, and that'd be Dallas Henline, our wastewater operations manager, and then some of his crew: Clint, Connor, Mark, Matt, Paul, and Rob.
Awesome. Yeah, as we go through these pictures, you'll be able to see them in here and kind of how they executed on it. One other thing kind of wanted to watch at is, can you kind of help us describe kind of what led up to the rehabilitation project and what kind of, deterioration your team was seeing in the manhole before your guys' work began?
Yeah, so this one, where this particular manhole is, we don't typically have issues here, so it's on our regular rotation of maintenance, but Where it's located is at the end of a dead-end street. And over the years, we've noticed people dumping, material on top of this manhole. It'll be covered with dirt one week, a couch the next, just all these various things. So it's not venting. And then when we went out and performed some cleaning at this manhole with the Vector, they were starting to see that they were actually sucking up parts of the bench in the trough area. And so that raised some, red flags on our end. And that's when we started looking at, what are some options we have here? This is an issue for us.
Okay. Yeah. Sounds like everybody probably on here has had plenty of parts of their system that have similar things and degradation and so forth. So totally get that. Also, on this project, presented some unique obstacles, particularly the fact that the bypass pumping wasn't feasible. What made it unfeasible and how did that influence your planning and the solution, you guys were considering as a district?
Yeah. So as we found the issue and as we're looking at solutions, thinking of, what do we do if we need to bypass pump? Roughly over 600 feet, between upstream manhole and downstream. We felt like that, we don't have bypass pumping equipment. That was going to be quite a cost and an effort for any of the rehab that might require that. And then just the nature of this, it wasn't just spalling, we had spalling on the walls of the manhole, but also the way that trough and bench were falling apart. We knew that we had to come up with a permanent solution that, would essentially, take on a structural component to this.
Yeah, for sure. I think that's a big thing in rehabilitation, more of the permanent side of rehabilitation than just kind of a Band-Aid, which, everybody's been guilty of. So that's good to see. And then, Geneva's engineering team, we used a 3D scanner to, scan the existing structure to design a, custom base liner at the bottom. Just kind of wanted to see, how did that process impact your installation and the overall outcome of what you saw with the product?
Yeah, so what you're seeing here is the actual submittal that we approved. And you can see on the left-hand side that scan, which I think was really helpful. Our manhole didn't have just a regular trough. It was pretty beat up just from, I think initially it was potentially a pour in place. It was a pretty rough transition and it was falling apart. So the scan, I think really gave us a nice view of that, as well as the cone and section where we were having spalling and you could see aggregate. That also kind of solidified the idea to have a permanent solution.
Yeah, that's awesome. Yeah, it's, super key in this process just to be able to really understand inverts, understand pipe type, and understand kind of what the bench is doing and what the troughs are doing for us on the manufacturer side. So it's good that as we went through on this, it helped out a lot. Tell us a little bit about the unique approach, your team took place in the liner, given that it had a 90-degree bend in the channel.
Yeah, so I think you probably noticed some pictures in the previous slides where they had straight through run. You can hold on or brace that with a 2x4 and pretty easy to then support it and lower it down. In our circumstance here, we had a 90-degree bend. And what we've done here is chose to penetrate just the sides near the top and then kind of hook up a three-way system where we were able to lower that down in and not get it, tilting or bending one way or another. Part of the concern with this was that we're making penetrations in that liner, but it was up near the top where your mastic would go around and cover that. So we felt pretty comfortable with doing that and maintaining that watertight seal.
Awesome. So this is kind of a picture of them grouting the actual piece, it looks like, kind of in there. Is that correct?
Yep. Once we got the base down in, we just mixed the grout and poured it in around the edges ourselves with, buckets and mixing on the surface and handing them down until that was filled up.
Awesome. So that kind of shows the guy doing that. And then also too, why performing this rehabilitation in a live sewer is always, can be challenging. How did the system allow your team to safely and effectively complete the work without, interrupting your service with the line and the water and the wastewater?
Yeah, that was one of the things that, we really did like also because, again, we didn't want to bypass pump. We wanted to be able to do this in the quickest amount of time. And just like any collection crew, they're pretty used to being around live sewer. And so they weren't scared of that. It was more of, are we going to create a backup or is there going to be some issue like that? And this system, when you drop that base in, you have flow going, but as soon as it settles down in there, now the flows just transition right to the base. And it's continuing through. Then these fuse locks sleeves that you put in there, kind of the same idea. Once you put it in there, even if it's not completely expanded and set, the flow will just transition right to that. And they go in pretty smooth once you have your base set in there. And the transitions are smooth as well. So comparable to like a spot repair liner in a pipeline. There's a little bit of a beveled edge at the beginning and end of this tube, and that allows the flow to continue. So we're not getting solid, hung up there or anything like that.
Yeah, that's awesome. Yeah, as a manufacturer, we definitely don't want to affect any kind of flow rate when we do this, and fuse lock is a big part of that, hooking onto those existing pipes going into the FRP. So that's great. And then this is also a picture of kind of the mastic. Is there any detail there, kind of how that went in with that C900 or anything on that?
Yeah, so starting at the bottom, you put your mastic in. You want to make sure you've got that around the edge enough. And then when you set the pipe down in, there's just some effort to make sure that you're getting that pipe set down on there and you've got kind of your weight evenly distributed along that mastic, which worked out pretty well. We had, a slight variation from one side to the other, but the mastic was, being compressed by that pipe on all sides.
Awesome.
So that was a pretty smooth transition. And then, kind of similar process at the top. Just make sure you're getting that set in the right location for that lid to sit down on and make that seal.
Awesome. That's great. One other thing I wanted to ask is this was, your team's first time using a hybrid PVC system. How would you describe your installation experience from the beginning to the end with your crews and, set up for completion?
Yeah. So a lot of guidance from Geneva. They had some installations in Arizona. They actually got us in contact with a contractor there, and they gave us a pretty good idea of what we were going to be up against, some of the grout that we'll need. Specifics down to, the specific grout and that, and then some tips and tricks that they learned along the way. So, I think preparation ahead of time, we took a lot of time to fully understand what we were going to need when it came to equipment, based on what we had available. So you can see here in the picture, we have a boom truck. We had an excavator to initially excavate and remove that cone section. So a lot of pre-planning and making sure we were ready when the material arrived on site. We used some kind of gripper hooks on the top of the PVC pipe to lift that and lower it down in. Depending on your depth, this manhole is around 12 feet, so we had to make sure that our equipment was able to lift that PVC pipe high enough to then swing over and lower into the hole. So, yeah.
That's awesome. Yeah. Just biggest thing is preparation is key, right? Making sure that you have all your ducks in a row so it goes smooth on site. So, one other question I kind of wanted to talk about is what kind of feedback did you get from, your maintenance crews, your field crews on completing like the installation? Did they learn some lessons that might help other, agencies that could be on here, consider a similar approach or anything there?
Yeah. So, we did it with our own crews. We had about 5 guys out there at a time, talking to them after they, everything you do, once you've done it once, you're better the second time. You know, they felt
Right.
like maybe 3 guys could be the minimum, but when you have more hands, it just, you know, it helps the process along. This particular crew, you know, they had an experienced lead, and then the others were fairly young, and we don't, you know, do construction projects in our collection crew normally. You know, they're doing the maintenance and cleaning and cammering of the lines. But they do have, you know, a lot of good knowledge on construction application. And so, you know, with that said, I think, you know, they did a really, really good job. We completed it in 3 days. The first day was mainly just excavate, get ready. Day 2 was installing everything, and day 3 was just buttoning up. You know, so the majority of the work happened in a day. Lessons learned would be to, you know, think about how you're going to hold things and, you know, lower them down in. Make sure you have the right equipment, you know, get your supplies lined up. And then we did have a little difficulty with the base. As we brought it down in, it wasn't sitting quite flush, the trough. And so, you know, I think the intent is that is manufactured based on the 3D scan. And likely you're going to have to chip away some of your, you know, either your bench or your trough to get that to fit down in there perfectly. So we did a little bit of that, and we actually shaved off a little bit of those connectors that, you know, you showed in those other pictures. But outside of that, things went really smooth, comparable to, you know, building a Lego set. You follow the directions and put it together.
Yep, 100%. You know, I think just like you mentioned, you know, obviously trough and bench and all those kind of conditions and degradation, you know, it's going to be so different as we go through different systems and so forth. So as us as a manufacturer, we do everything we can to get as close as we can with our tolerances, so that essentially when it's on site, you might have to do some roughing up and then set it in there. But for sure, that's good. One other question is, you know, how confident are you in the long-term performance of the system in the terms of corrosion resistance and maintenance needs on something like this?
Yeah, so I, you know, mentioned previously, we wanted something that was going to last. It was going to structurally hold up. And since we've installed this, we've had, you know, been out there and cambered for different reasons, and it's done nothing but perform well for us. We're confident because of the materials used, that it will last, you know, those 50 years plus. And so, you know, I think if we come to a situation like this again, this is going to be the first thing we're looking at. Is this going to work for us?
Awesome. Yep, for sure. It's one of those things that we built to last, and I think you get what you paid for, right? Many agencies have come to us where they put, you know, band-aids on certain things, and eventually it comes back, and then you spend probably 2-3 times more sometimes, just as Elena represented. You know, for other agencies, this might be, you know, facing similar corrosion or bypass challenges. What would you tell them about your, well, experience about the hybrid PVC manhole system?
Yeah, so it's, you know, I think it has its applications, right? Elena showed a few different options. We did consider, you know, a slip-in liner that would take care of this falling on the section and cone, and you know, for us, the bench was a big issue as well in the trough. And, you know, so this was a no-brainer, really. We didn't have the budget at the time. We didn't know this was there. But it is economical in the sense that now we've got a product that will last for a very long time without us worrying about that. So, you know, I would definitely recommend it if it fits your application. You're on the fence, it's a good product.
Yeah, awesome.
And I think if you've got a crew that, you know, if you got 1 or 2 and you have a pretty good crew, they're capable. They can do it.
Yep, we've seen that across many districts that feel like once they understand the scope of it and they understand kind of how simple it is to kind of get it in. Some have inside crews where we feel like we could try it, and you know, a lot of them have, you know, honed in on a low tide or something that's kind of off the beaten path to give it a try. And I think once they realize, okay, it's not too bad, sometimes they have tried it in-house. So it's something to think about as a district to save a little extra money there for sure.
Yep.
Awesome. Okay, well, wanted to kind of go over some questions here. I know we've got a couple in the chat, so feel free to start putting more into the chat. And we can kind of divvy it up here. Elena, I guess we'll go over to you.
Yeah, Trevor, thank you so much for sharing your experience in using this product. I had a couple of questions to you. So this solution, you can actually install it with the select backfill, like everything above the former cone, everything where the former cone was, you can actually use the select backfill to fill that space up. And in your case, I believe you used flowable fill. Can you explain the choice?
Yeah, so well, we dealt flowable fill to the surface. So what we did was when we removed the cone, we also excavated down, roughly maybe a foot on that section. And then once we had the pipe in and grouted, then we put flowable fill there just to kind of steady that up. And then we use native for the, about 6 or so feet up to the surface.
Great, thank you for explaining. Yeah, in general, this manhole has been tested for HS20 loads, so it's capable of sustaining the highway load without the backfill support. So if you want to add additional strength, yeah, backfill is great, but you can also the annular space in between the existing wall and PVC riser, yes, you fill it up with the flowable fill or grout, and the rest can be filled up with the either native soil or backfill or select materials. But yeah, also, what are your thoughts on economics? You mentioned that you guys did not have a budget initially, but did you consider economics of this solution, and also how did it compare with other solutions that you considered?
We did some rough napkin numbers of, if we were to have a contractor come do, say extreme case, a complete replacement of the, base and sections, bypass pumping, or if that was just the kind of cured liner. Those are things we can't do ourselves. And so we felt that was a cost that was going to exceed what the quote was we got from Geneva. So that played a big part. And then just the longevity of this.
Great. Yeah, for sure. And what do you remember what included into the preparation of the surface before you slipped in the riser?
To the existing manhole surface?
Yeah, was it just like pressure washing, or did you guys do something
I
else?
don't know that there was much preparation, to be honest.
Okay. Yeah, this method does not rely on chemical adhesion between the host manhole and the new riser, so the preparation is not as important for this case, which is also a plus. And of course, yeah, Trevor, I really appreciate it was very interesting to hear the first-hand experience notes from you.
Yeah, welcome.
And we had some questions from the audience, and if you have additional questions, feel free to type it in. If we do not have enough time to respond to them, we will respond to you individually. So one of the questions was, what kind of scanning technology do we use? Is it performed by Geneva or NWPX? And is there some partners performing this? And have we performed a broader scanning of numerous manholes to determine whether they need a rehab? So to answer this question, it's a case-by-case basis, right? So we're located in Utah. So if for the case of Magna Water District, we scanned the manhole and we came up with a digital model of the manhole. If you have a project outside Utah, we can either rent the manhole to scan it, but you've got to know how to use it, or we can use scans made by the third party. I think there are a few companies available now who go around and scan manholes in bulk. They determine the condition of existing manhole, and then I don't know if they can recommend whether it needs rehabilitation, but we can use the digital scans to manufacture your custom-made baseliner. I hope that answered the question. Then another question we had was how deep these manholes can be, and other limitations, and how deep these manholes can be. Yes, there are limitations, of course, as any manhole. As you know, like in super deep manholes, even for concrete, the deeper you go, the thicker your manhole needs to be because of all that pressure from the soil. The standard length for these manholes is typically comes in about 20 feet long. So with 20 feet long, we have no problem at but if it's a little bit deeper, yes, we can stack those manholes, but you can also use, let's say, instead of grouts, you can have using high strength concrete, like self-consolidating concrete in between in the annular space to increase the strength. So that will allow you to go a little bit deeper. So if you have any particular cases, and if you have concerns about particular depth, yeah, feel free to contact us and we will determine whether it's suitable for you for your case.
Yeah, I'll take this one real quick too. Just the cost effectiveness of the solution. Obviously, we've gone through this quite a bit with different quoting process, and I can get specific to your project. So feel free to email me on that list. And yeah, cost effectiveness though is very similar to like what a bladder cost would be. It's pretty similar to that, but each project's a little bit different. So we would just want to kind of look at what you have and what your scope is, and for sure get you guys a quote. So feel free to send over some information. We'll get something out to you.
There was a question about the original strength of the manhole, how strong the manhole needs to be, and yeah, these manholes were designed to support the load without the backfill, and yeah, they do not rely on existing strength of the manhole. So I guess the rest of the questions can be answered offline, and I'll be happy to contact you, all of you individually.
Okay, wonderful. Well, Elena, Jake, thank you very much. And really special thanks to you, Trevor, for being here and sharing about the Magna Water District project. And kudos to your team for a job well done. I mean, I think that it's definitely a testament to your crew in the field for making this project a success. And we're really happy to have been able to, supply a solution that worked out for you.
Thank you, everybody.
Thank you.
Thank you.